Hello. Hello.
Hello.
Yeah.
Good afternoon, sir.
Good afternoon. Okay. So we'll do PNC and probability questions then, right?
Yeah.
Okay. So question one is this. A library has 5 indistinguishable physics books, physics books, 4 indistinguishable maths books, and 3 indistinguishable chemistry books. In how many distinguishable ways? In how many distinguishable ways can a student take home? First part is take home 6 books. Second part is 6 books taking at least one of each subject. And finally, third part is 6 books taking not more than 2 of each subject. Not more than 2 of each subject. That is the question. Just try to solve the first part first. How many different ways can you take out 6 books?
Is it 12 factorial divided by 5 factorial, 4 factorial, and 3 factorial?
That will select how many books then? Like, how are you thinking that that would be the answer? Like, 12 factorial by 5 factorial, 4 factorial, 3 factorial is a number of ways to arrange all of these books, right? Right, in a line, if you want to arrange 5 plus 4 plus 3, that would be the answer, right? But that is not ways to select 6 books. You have to select 6 books. Are you understanding what I'm saying?
Will it be 12C6 then?
No. Well, C6 would be if all the books were different and 12 books were there, that would be number of ways to select 6 books, right?
Yeah.
Here, this is not the case. There are 5 exactly alike physics books, 4 exactly alike maths books, and 3 exactly alike chemistry books. And how many different ways can a student take home 6 books? You have to think of cases. Total number of books has to be 6. We have to take cases. What are the different cases by which I can take 6 books? When you say 12C6, it means select 6 things from 12 different things, right? When you say 12 factorial by 5 factorial, 4 factorial, 3 factorial, that means arrange 12 things out of which 5, 4, and 3 are alike. These are not at all what we need here. Think without thinking of trying to get the answer fast, just think of how many ways you can do this. Like 6 books. What are the cases by which you can get 6 books?
Like you can take
5,
5 of physics.
5 of maths, right? 5 of maths, I think. Or 5 of physics. 5 alike and then 1 different, right? This is one possibility.
Yeah.
So 5 of physics can be taken in how many ways? Only one way, right?
Yeah.
Because they're all similar. There's only one way to select all 5 of them. And 1 different can be taken in how many ways?
2 ways.
2 ways. Either you can take chemistry or either you can take physics, maths, right?
Yeah.
So basically this is 2C1. Out of the 2 other types of books, select one, right?
Yeah.
So now another case could be 4 alike and 2 other books 2 alike, right?
Yeah.
Which are different. Other alike, right?
Yeah.
Because you cannot have 6 alike. All 6 cannot be of the same type because there are no 6 books which are same, right?
Yeah.
How many ways can you do this one?
For 4 alike, it could be 5C4.
No, it will not. So this is where you are confusing. It cannot be 5C4 because all the 5 are alike, right? 5 alike, no.
Yeah.
Out of which selecting 4 is basically there is only one way to select, no, not 5C4 ways.
Okay. Yeah.
Understand what I'm saying?
Yeah.
Physics books are not different from each other. It's like this. These are the books. Selecting 4 of them is just one way. You just pick 4. It's not 5C4 ways where they would have been different, right?
Yeah.
But there is a thing that there are maths books also, there are 4, no?
Yeah.
So you could do either 4 physics books or 4 maths books.
So 2 ways.
So this part can be done in 2 ways. And then the next part, 2 others alike. So depending on what you selected here, there are 2 other types of books left, right?
Yeah.
Let's say we selected 4 physics books here in the first part. Then maths and chemistry are left. So you could select 2 from maths and 2 from chemistry, right?
Yeah.
So again, 2.
Yeah.
So this is 4. Then 4 alike and 2 different could also have been an option there.
Yeah.
So again, 4 alike can be done in 2 ways and 2 different, right?
Yeah.
Can be done in only one way then, right? You have to pick one from here and one from here,
Yeah.
right?
Yeah.
So 2 into 1. Then what are the other cases? 3 alike and 3 others alike, right?
Yeah.
3 alike, 3 others alike. How many ways will this be possible?
3 ways for 3 alike,
Hmm.
and 2 other for 3 others alike, 2 ways.
3 ways for 3 alike. Uh, 3 others alike. So actually, suppose uh, you have to select here 2 groups out of the 3 groups, right?
Yeah,
So there are, this is the physics group, this is the maths group, and this is the chemistry group. There are 5 here, 4 here, 3 here. And from all the 3 groups, you need to select 2 groups. From both the 2 groups, you'll pick 3, right?
yeah,
So how can you select groups? You can do 3C2, right?
yeah,
So that will give you 3 ways to select the groups. So what
yeah,
I'm saying is there any other possibility than physics, maths, physics, chemistry, maths, chemistry? Is there, what you were saying was 6, right?
yeah,
Is there anything else other than this possible,
no,
right?
yeah,
You understand what I'm saying?
yeah,
You can pick 3, 3, or you can pick 3, 3, or you can pick 3 and 3, right?
yeah,
There's nothing else. So it is not 3 into 2. Why is that mistake being made? So what you said, first pick one group, right? That can be done in 3 ways. And then 2 are left. And then out of the 2, you have to pick one. Why is that giving a wrong answer? Why is that giving 6 when it should be 3? Uh, huh. The reason it is giving that, it is giving wrong answer, you realize, no?
yeah,
Normal way to think about it, right?
yeah,
It is giving wrong answer because the groups have the same size, right?
yeah,
So you remember, if you arrange things into groups, right? Then, like, let's say we had a problem 6 factorial by 3 factorial, 3 factorial, right? Like, divide 6 where 3 are alike and 3 are alike, right? Number of arrangements, right?
yeah,
But then you have to divide by 2 factorial because the groups of the same size, right?
yeah,
You have seen this, no? When groups are of the same.
yeah,
Basically, what you're counting is you are counting M and P as separate.
yeah,
You understand?
yeah,
So therefore, your answer is 6, but actual answer is actually 3, right?
yeah,
So the answer here is 3 ways. Then the next case is when you have three alike, and then 2 others are alike, and one is different, right?
yeah,
One is different. Okay. So now the group sizes are different. So now you can do 3C1 for the first one, 2C1 for the second one, and then last one is 1, right?
yeah,
Because groups are not the same size, then you would have not have to divide by 2 factorial. This answer will be 6, right? Because it matters that physics, you could have done physics 3, maths 2, chemistry 1, and it will be different if you do chemistry 3, maths 2, physics 1, right?
yeah,
So now the order matters, right?
yeah,
You understand? It was not different here because both were 3.
yeah,
So 6 ways to do this. And finally, we have two, two alike, and two alike, others alike, 2 others alike, and 2 others alike, right?
yeah,
right?
Yeah.
If you think about this in the regular way, like there are how many ways to select two? 3C2, right?
Yeah.
And out of this two, you can select in two ways, 3C2 into 2C2 into one, right?
Yeah.
But the group sizes are the same, right?
Yeah.
And there are three groups of two, right?
Yeah.
You divide by 3 factorial. So you'll realize that this will be 3 into 2 by 6, which is one way, right?
Yeah.
If you don't divide by 3 factorial, you will get 6 ways. But actually, that will be wrong because then you are actually, there's only one way to do this: physics 2, maths 2, chemistry 2, right?
Yeah.
It's not like there's any other option left, right?
Yeah.
So group sizes are same here. So you have to divide by the number of equal groups, right?
Yeah.
So now no other way is possible. So total number of ways of selecting 6 books in this situation would be just the addition of all of these. So 2 plus 4, 6 plus 2, 8 plus 3, 11 plus 6, 17 plus 1, 18, right?
Yeah.
Now that we know how to do this, now you can try the rest of the things where he's saying 6 books taking at least one of each subject, right?
Yeah.
So some of the cases can be excluded now, right?
Yeah.
6 books taking at least one of each subject. So you will notice which cases matter here. This case is fine, right?
Yeah.
And this is not fine, right?
The fifth and the sixth one.
This is fine and this is fine, right?
Yeah.
Correct.
Yeah.
You just add those cases 2 and 6 and 1. So 9 ways to do the second part, right?
Yeah.
And finally, taking not more than 2 of each subject. So only last case, right? Then
Yeah.
because every other case there is 3 of one subject.
Yeah.
So last one will be one way, right?
Yeah.
Basically, the idea is when you count things, keep in mind whether the objects are different from each other or indistinguishable from each other. If the objects are indistinguishable, the counting has to be done very carefully because you can't use the regular 12C6 or stuff like that, right?
Yeah.
You have to think of, okay, if I select some, there's only one way to select m things out of n same things, not ncm ways, right?
Yeah.
There are n identical things. Selecting m from there is only one way, right?
Yeah.
So that is something that you need to be aware of. Then um, let's do this one. Okay. Okay. This is the question. A bag has five. A bag has 5 white marbles, 3 red marbles, and 5 blue marbles, right?
Yeah.
Uh, the marbles are drawn one by one without replacement. The marbles are drawn one by one without replacement till all the marbles are drawn. till all are drawn. Marbles of each color are indistinguishable. Marbles of each color are indistinguishable. And the question is, in how many ways may one draw marbles out of the bag? In how many ways can they be drawn? Ways can they be drawn? If all the blue ones are drawn in odd numbered draws, in odd numbered draws, or all the blues are drawn in even numbered draws. So either they are coming out in the odd numbered draws or in the even numbered draws. So in how many ways may one draw the marble so that all the blue ones are coming out in odd numbered or even numbered draws, right?
Yeah.
So actually, there are 13 marbles here. 538 plus 513, right?
Yeah.
So basically, there will be, you can write the draws like this: draw one, draw two. There are 13 spots, right?
Yeah.
3, 3, 6, 3, 9, 3, 12, and 113, right?
Yeah.
Either like all the blue ones have to occupy the even numbered spots or the odd numbered spots. Like think of, let's first focus on the odd numbered draws only. They have to come on these spots, right?
Yeah.
Right?
Yeah.
There are 3, 3, 7 odd numbered draws and 6 even draws, right?
Yeah.
So now let's try to count this. Like how many ways can you, like basically it's like putting all the marbles in a straight line, right?
Yeah.
And the blue ones have to be on these spots only,
Yeah.
right?
Yeah.
5 spots will be taken, so 7C5, right?
Yeah.
And after that, 8 things are left, 8 other spots are left, right?
Yeah.
So that has to be filled by 5 white and 3 red marbles. How many ways can you fill that, right?
Yeah.
So 7C5 into what should we write?
Like they can be anywhere, right? So
8 spots are there, you have to arrange 5 white and 3 red in that.
8 factorial.
8 factorial would have been correct if all the 8 things were different from each other.
So 8 factorial by 5 factorial and 3 factorial.
Hmm. If the objects are not different from each other and there are some which are alike, then obviously you'll have to divide by those numbers, no?
Yeah.
Where have you read the PNC part from so far?
I've done it from RD and I have done bits of it from Alan.
Hmm. So focus on the Allen book a little bit because these cases are there. These types of things are explained there, I think. So don't confuse it with like right now it seems like you're unsure whether it is 8 factorial or 8 factorial by 5 factorial, 3 factorial, right?
Yeah.
So if you're unsure, you need to focus on the theory and the cases that are done in Allen. Do all the beginner boxes in the Allen book and go through the Allen book once more and see. And you can ask doubts if there are parts which you don't understand there. Okay.
Yeah.
So this is the correct way. But we said or, so we have to add the other cases, right?
Yeah.
So count the other cases now. Tell me what it should come as.
6C5
Hmm.
and it will be 7 factorial by 5 factorial into 3 factorial.
Yeah. 7 factorial by 5 factorial, 3 factorial. So this answer, this addition will give you the right answer, right?
Yeah.
Uh, then, okay, so let's do this one. Let there be, let there be a large pile of red, white, green, and blue balls, where balls are all alike except for color, where balls are all alike except for their color, right?
Yeah.
Find the number of ways, find the number of ways to select 20 balls from them, 20 balls from them, so that one, the selection has at most 3 green balls. This is the first. And the second case is the selection has an even number of white balls. An even number of white balls. Focus on the first part in the beginning. You have to make sure that there are at most 3 green balls. And this is a large pile, that means there are many balls of each kind.
So we'll have to make cases, right?
Which cases?
For the first one, it would be what if there's no green ball and 1 green ball, 2 green ball, and 3.
Mhm. That could be one way, yeah.
But for that, if I do it that way, then for the first category itself, I don't know how many of them are there for red, white, and blue each. So I can't divide anything.
See, what you have to do is red plus white plus green plus blue should add up to 20, right?
Yeah.
And here the condition is that G should be less than equal to 3, right?
Yeah.
And everything else will be greater than 0 and stuff, right? Greater than
Yeah.
equal to 0. It could be like this, right?
Yeah.
So the number of ways to select is basically number of ways to solve this equation keeping G less than equal to 3.
Yeah.
So do you know how to find out the number of ways to solve this equation?
Will we do AMGM?
No. AMGM, why will that be relevant here? Like, how is AMGM coming?
Okay, it won't do anything.
Number of ways to solve an equation. This type of question have you ever seen? To solve an equation. Let's say x plus y plus z is equal to 35. When x is greater than 0, y is greater than 0, and z is greater than 0. Have you ever seen such questions?
I think I have.
Hmm. So there is a way to solve this. If you don't know the way, then you can't solve this question. So if you don't remember, I can discuss it. There is a standard procedure to solve this.
Yeah, I don't remember it.
Hmm. So, suppose you have to solve x plus y plus z is equal to n, right?
Yeah.
How many ways can you solve this equation? It is given that x is greater than equal to 0, y is greater than equal to 0, and z is greater than equal to 0, right?
Yeah.
Then, like, this is called the stars and bars method. Basically, what you imagine is that there are n stars. These are n ones, right?
Yeah.
Which are going to be put in these buckets, right?
Yeah.
Some of them will go in X, some of them will go in Y, some of them will go in Z, right?
Yeah.
So there these n things, put them on a line. N things, put them on a line. N stars basically, right?
Yeah.
And think about it. How many bars or bars will be used to partition the group into separate buckets, right?
Yeah.
So how many bars do you need to make it into 3 buckets?
Two.
You need only 2 bars, right?
Yeah.
Put a bar here, you can put a bar here, and this separates it into this, this, and this, right?
Yeah.
If the bars were, for example, if one bar was here and one bar was here, then basically one bucket has 0, one bucket has this many, one bucket has this many, right?
Yeah.
This could have been here also, right?
Yeah.
If the 2 bars were successive, for example, if one more bar was here, right?
Yeah.
That means the middle bucket has 0, and this bucket has this many, this bucket has this many, right?
Yeah.
So basically the idea is how many bars are needed, and right now you can see that there are 2 bars needed, right?
Yeah.
So you'll put the 2 bars somewhere here, right? Correct.
Yeah.
So total number of stars and bars are how many? It will be n plus 2, right?
Yeah.
N plus 2 stars and bars, right?
Yeah.
And basically, uh, We have to find out number of ways to arrange this, right? This sequence. How many such sequences are possible, right?
Yeah.
Each such arrangement of n plus 2 stars and bars gives you one way in which x, y, and z can be filled, right?
Yeah.
So think about it. There are actually like n plus 2 spots, n plus 2 spots on the ground. There are n plus 2 things, bars plus stars, right?
Yeah.
And you have to pick two spots for the bars, right? Out of that.
Yeah.
Like suppose there are dots here. We know that there are n stars and two bars, right?
Yeah.
There are n plus 2 spaces on the ground. So if you select any two spots for the bars, right? That can be done
Yeah.
in n plus 2 C2 ways, right?
Yeah.
And the remaining will be stars, right?
Yeah.
That is a count of how many different ways you can arrange the bars and the stars in this way, right?
Yeah.
Are you understanding?
Yeah.
So basically, n plus 2 C2 will be the answer. Number of ways to do this would be n plus 2 C2. In general, if I had like this, x1 plus x2 plus x3 plus so on, so many variables xr, right? Is
Yeah.
equal to n. So I have to solve this equation where each variable is positive and all, right?
Yeah.
Then I would say that there are n stars and how many bars are needed?
R minus one.
R minus 1 bars. So total number of things are n plus r minus 1, right?
Yeah.
That many spots on the ground, out of which you have to put the bars in those spots, right? So select the r minus 1 spots for the bars, right?
Yeah.
This many spots and put the bars in some of those spots, right?
Yeah.
Rest will be stars here, right?
Yeah.
So this is the number of ways to solve this equation under the condition that x1, x2, everything is greater than or equal to 0, right?
Yeah.
Now suppose a slightly modified question here. If someone said that no variable can be 0, right?
Yeah.
Like each variable has to be 1 at least. Like you have to give something to someone, right?
Yeah.
So then basically the restriction is no longer this. The restriction is now x1 greater than or equal to 1, x2 greater than or equal to 1, and so on, right?
Yeah.
xr greater than or equal to 1. So in that case, how will we solve it? We will say, okay, every bucket gets at least 1 star. So why don't we already give one star to each of those buckets, right?
Yeah.
We already put a one star in each bucket. And the next question becomes, we have how many stars left now, right? We have n minus r stars left, no?
Yeah.
And now you still have to solve this question. What happens to the n minus r stars? Where do they go, right?
Yeah.
Everyone already has one, right here.
Yeah.
And after now we have satisfied the condition of the question, right?
Yeah.
Now you can give 0 and stuff from the remaining, right?
Yeah.
So now you will say n minus r stars plus r minus 1 bars, c r minus 1, right?
Yeah.
So you will do n minus 1, c r minus 1 if the variables are non-zero, are have to be non-zero, right?
Yeah.
If the variables can be 0, this is what comes as the answer, right?
Yeah.
If the variables can't be 0, it has to be something everyone should get, then you will get this. You already give 1 1 1 1 to everyone, and then you're left with these many, right?
Yeah.
So this is the general approach to solve these kinds of equations. uh, Now the question should seem pretty easy. You have red plus white plus green plus blue is equal to 20, right?
Yeah.
and G should be less than equal to 3, right?
Yeah.
So, and R and W and B can be greater than equal to 0, right?
Yeah.
So, okay, G is less than equal to 3. That means G can be 0, 1, 2, or 3, right? 4 cases,
Yeah.
right? So, if G is 0, first case, right? The equation is R plus W plus B is 20, right?
Yeah.
How many ways can this be done according to the stars and bars method?
It will be 20,
Hmm.
22C2.
Hmm. That is the answer for this, right?
Yeah.
Case 2 would be R plus W plus B, but G was 1, so it is 19, right?
Yeah.
That answer would be
21C2.
hmm. In case 3 would be 18, right?
Yeah.
So it will be 20C2.
Yeah. And the last is 19C2.
Last is when it is 17 like this, and the answer will be 19C2. So you just have to add these four: 19C2 plus 20C2 plus 21C2 plus 22C2, right?
Yeah.
So do the calculations roughly. I will just want to check the answer. So 19 into 18 by 2, right?
Yeah.
So 19 nines are 171 here. 20 into 19 by 2, so 190 here. 21 into 20 by 2, so 210 here. 22 into 21 by 2, so 21 into 11, and 210, 231, right?
Yeah.
So adding all this, we are getting 441 plus 631 plus 171, 802, right?
Yeah.
So that is the answer. That is correct. You understand?
Yeah.
This is your stars and bars method. The second part of the question was the selection has an even number of white balls, right?
Yeah.
The selection has even number of white balls. So R plus W plus G plus B is equal to 20 when W is equal to some 2K, right?
Yeah.
So in general here, like it will be annoying to take too many cases, right?
Yeah.
Because you'll have to take so many cases till 18 and all, right? 20 and all.
Yeah.
So it will, because after that, if even if you take all those cases, you will have to add all the answers, right?
Yeah.
So ideally what you should do is you should say R plus G plus B is equal to 20 minus 2K, right?
Yeah.
Where K can go from 0 to 10, right?
Yeah.
Correct.
Yeah.
And then try to solve this equation. This is a summation now.
Yeah.
Like K is a variable and you have to sum it up from 0 to 2K, all the cases, right? So in this general situation, what is the answer? The answer will depend on K, right?
Yeah.
Number of ways to solve this equation would be how much?
20 minus 2K plus 2 C2.
C2, right?
Yeah.
And we have to sum it up for K goes from 0 to 10, right?
Yeah.
So that is your question. Now you can simplify this a little bit. This is summation of 22 minus 2K C2. K goes from 0 to K goes to 10. So this will be 22 minus 2K and multiplied by 21 minus 2K divided by 2 fact 2, right?
Yeah.
Summation K goes from 0 to 10. So it will be 11 minus K multiplied by 21 minus 2k, right?
Yeah.
So this summation can be done because you can just multiply 21 into 11, 231 minus
Yeah.
21k and plus minus 21k and minus 22k. So you'll get minus
43.
43k plus 2k square, right?
Yeah.
So this is a straightforward summation.
Yeah.
231 into k, 0 plus 1 plus, there are how many terms? 11 terms, right?
Yeah.
So 11 minus 43 into k goes from 1 to 10. So it is 110 into 11 by 2, right?
Yeah.
Plus 2 into k from 1 to 10. So this is 10 into 10 plus 1 into 20 plus 1 by 6, right?
Yeah.
So you will get 43 into 5 into 11. So 231 into 11 minus, this is 215, right? Into
Yeah.
11. So you'll get 16 into 11 is left after subtracting, right?
Yeah.
And here you get 21, and here divided by 3, 7. This is 2, and this is 5. So 2 into 5, 10. 10 into 11 into 7. So 77 into 10, 770, right?
Yeah.
So 770 plus 176. So you will get answer
946.
946. So the answer in this case is 946. Maybe there is a silly mistake somewhere because his answer is 948, which I think his answer is only wrong. So 946 will be correct, unless we have made some small mistake somewhere. You understand?
Yeah.
So basically, this case, there were so many cases because it was even that we can't do it directly one by one and add it up. So we took a variable where the k goes from 0 to 10, right?
Yeah.
And we did it like this and we counted this. This will depend on k, and then you add up the final answer properly, right?
Yeah.
Okay. Uh, then actually what you should do is do a little bit of revision first. Like do your Allen book and tell me if there are problems in that first. Okay.
Yeah. I'll try solving the exercise.
PNC beginner boxes first, do all the sections because I feel like your theory is a little weak right now.
Okay.
Do all the beginner boxes first and then we can discuss more questions. Okay.
Yeah. Okay.
We will do classes tomorrow also. We'll do a few consecutive classes for PNC and probability till it is okay. Okay.
Could we keep? Okay. Yeah. 3:30 only, right? Tomorrow.
Yeah, yeah.
Yeah. That's fine.
And what is happening in your tests and all, Allen tests? Or how are your scores and all?
Allen tests. They actually started doing it like in the campus.
Hmm.
So I didn't attend the last one. I am starting my classes from Allen tomorrow again. So I'll be going tomorrow.
In which campus? Marathon.
No, Whitefield.
So you are going to physical classes.
Yeah, they have like started it again because JEE got postponed. So they're like, come and we'll discuss some stuff.
Hmm.
So my dad was like, you should go try once. If it's not, if they're just solving questions and you think you can do it yourself, then don't attend, but just for checking what's happening.
So last few tests and all, how much were you getting?
Last they had actually like they for 7 days they had the same paper
Hmm.
in all different campuses and it was in the center, so you could have gone, but I had my pre-board, so I did not go for the last test, so there hadn't been any much
Hmm.
tests.
Hmm.
The last test I think I did, I had gotten around 240,
Okay.
and
But
after
now the
that
tests will be frequent, no? Now from
yeah,
now.
it's regular.
So let me know what marks you're getting if there is any problems. If it is above 200, it's fine. So you need to Keep it above 200 for mains. And advanced and all, they have also started preparing for that or just focusing on mains?
Advanced also now the new timetable from I think 16th April they're having advanced papers majorly.
Hmm.
So it will be like two advanced and one mains in between. So it will be
Hmm.
most of advanced. So I think I'll start giving them as well.
Yeah, yeah, give the advanced papers, and if you can get the paper, share it with me so that we can also discuss.
Yeah, I'll do that.
Okay. Tomorrow we'll do at the same time then. When is
Yeah.
your Allen classes going to be if they are there physical or not?
5 to 8.
In the evening.
Yeah, in the evening and Tuesday, Thursday, and Saturdays only.
Okay. Okay, fine. Yeah, I'll see you tomorrow then.
Okay. Thank you.
Hmm.